right now for that. Are you good to go? I see that you are chatting. All right, we are on. So I'm gonna turn him to you guys, and I might have to adjust it because I just adjusted it again because I'm so professional. This is not Sky. This is Phil Plait. And let me turn on the. There he is. And I'm joining the audio. Hello. Phil, can you hear me?
Oh, I can. Hang on. Here we go. Try that.
That's good. I'm going to need you turned up a little bit more. I can do it.
I can do it here too. Oh, I remember how to do it.
Guys, this is Bad Astronomer. Hi.
How about this? Is that better?
Yeah, that's good.
I can also move in.
Yeah, no, it's okay because I can control a lot of it too. I can tell you read the instructions, by the way.
Yes, I did. I sometimes do that.
Not many do.
I don't see you. Where are you?
I am on my stream, but you're not going to see me on the Zoom because I'm using my camera capture right now for the stream, the live stream.
Oh, okay. So
Yeah.
I will see you delayed. I see you on my screen, miming. You're saying things. You're looking at me.
Yeah.
And I'm sitting there, and I don't hear anything because I have it muted. So this is all very peculiar.
I know, it's so weird. So there is a delay on the live stream, but now you can hear me real time. So this is
okay, great.
Yeah, it's weird. I was saying that would be a good thing to talk about, but not really. I'm trying to think of how that would even work with anything remotely astronomy related, but I don't think we could do that actually. First, wait. First thing first, Dr. Phil, louder. Do you guys need him louder? I can do that. I have like three different
I can sit
settings.
closer too.
I think that's good actually, right there.
I'm on a rolly chair, and every time I move it, it's like I'm drifting in space. Here we go.
Yeah, no, I turned you up on the OBS, and you're pretty good there too. That's great, perfect, awesome. Hey, I used to watch this guy's YouTube videos. Hey, do you want to tell us about who you are?
No. Yeah, sure. Hi. My name is Phil Plait. I am an astronomer, and although I don't do sort of research and everything like that anymore, I used to. I'm more into science communication these days. So I've been writing a blog. I've written a couple of books, done some TV shows and things like that. Just basically to do what you're doing, is to try to make science a lot of fun. I want people to enjoy it as much as I do. I want them to see that I really, really love this stuff. And I think that sort of enthusiasm is infectious. And that's what I want to do. And I started doing sort of straightforward science communication, but for a long time, I was debunking myths and misconceptions about astronomy. And that's where the term bad astronomy came from. And it's why my brand is basically bad astronomy, bad astronomer. But I don't do that as much anymore now. Now I'm mostly just writing about straight science and having a ball doing it.
Yeah, no, and that you answered my question. So Bad Astronomer was birthed from. I want a little bit more detail on that because that was one of the things I always wondered. Like why that?
Basically, it's debunking bad astronomy. People are going out there claiming this, that, and the other thing. The examples I usually use are that, for example, the full moon looks big on the horizon because the atmosphere is acting like a lens and magnifying the image of the moon. It turns out, no, that's not it at all. It's just an optical illusion. And I would write about things like that. And sometimes it was something like that. It might have been something a little bit of a bigger deal, like debunking astrology or UFOs. And I hate this, but I got a huge career boost by ripping apart a TV show that claimed that the moon landings were faked. And it really did sort of launch my career. My website was doing okay and everything, but after that, it was just kind of went viral at the time. And so I'm kind of conflicted about that TV show. I owe my career to it, but boy, oh boy, was it a terrible TV show. And so a lot of these things are more important. And over the years, I've actually tackled critical ideas like how the government is abusing science all the time, and how climate change denial, anti-vaxxers, all that sort of thing, anything based on science that people can twist, was something I was jumping in and trying to correct.
Yeah, no, and I actually really appreciate a lot of that too, because there is so much going on with it, as far as just fake news as a whole, and also I know that I've noticed that kind of switch to more of the latter of what you were just speaking of. That's a real thing. Like climate change, I always hate to say to people like they're going to brand me as a hippie. But I tell them like Earth already has its own agenda, and we're not helping that at all. So planets behave the way they behave, and then you put us here, and we kind of make that a little bit worse. Okay, so I'm being a little nice. See, do you already see? Right. See, you can go ahead and say that. So, and this is good because I also have, Pamela, Dr. Pamela on here quite a bit. And so I allow my guests to kind of express more about what they're passionate about because, it is important. It's something I take in. But I know that there's so many people out there that are like, oh, it snowed like, a foot here in Louisiana. I'm like, yeah, that's not supposed to happen. And that's not a proof of climate change not happening. In fact, that's pretty good, actually. Good evidence for it.
Yeah.
Yeah, they seem to relate it to cold, and that's why climate change is better than saying global warming, because then people get all literal with it. So that's where that came from. And so you guys, I have a command in here. If you do guest, it has as much of the information I could encapsulate in a small area without clogging chat.
Oh, I saw that. Yeah.
Yeah.
That was pretty good.
Okay, good. I hope, because there's so much stuff. But I know that also one thing that I wanted to talk about with you and some of the things that you describe really well, like you said, so you're very enthusiastic about talking about science and making it interesting and fun, because it really is, like, especially space. Space is great. And a lot of he has this crash course astronomy, guys, and it's amazing. It's mind blowing, and that's, yeah,
a lot of work.
It is.
I'm glad you like it.
Oh man, it's such a great source. I have to watch those things over and over again because there's so much in one section, but that's not a bad thing. I'm willing to do that. Tell me about your work with Supernova 1987A.
Oh, golly.
Yeah, I'm taking you back.
My brain for
I
that.
know.
I've always been interested in exploding stars and things at sort of that end of astronomy, black holes and neutron stars, all that kind of stuff. And I was in grad school at the University of Virginia when was that? 1988, 1989. And I was wrapping up my master's degree looking for a new project. And it turns out my advisor said, hey, look, Hubble Space Telescope is going to launch in a couple of months. And one of the first things we're going to be looking at is this star that blew up in 1987. Now, I already knew about that. This was a star that blew up. The light reached us in 1987. It was the closest supernova in roughly 400 years. And it had been about 3 years since it blew up. And everybody all over the world had been observing it. And we had a lot of interesting observations, a lot of interesting data, but we didn't have really high resolution, sharp data. And that's what Hubble was promising to do. Mind you, this is before launch. So I said, yes, absolutely. I want to work with this huge telescope that's going to be observing this thing and showing it to us in detail for the first time. And then they launched the telescope. We found out that the mirror was out of focus. And I wonder how many folks here in the chat room just watching us right now even remember this. I mean, it's been 28 years, but when Hubble launched, the mirror was ground incorrectly. It had the wrong shape. And so all the images that came down were out of focus. They were still in many ways better than what you can do from the ground, but there were a lot of real problems with them. And so I spent the next basically year and a half, 2 years learning how to deal with that. But what I studied was this ring of gas around the supernova. So the star was blowing off its outer layers for thousands of years. Then it blew up. And when it blew up, it lit up all that gas around it. What we found was this ring, this gorgeous ring, and these two other rings. So it was kind of shaped like an hourglass with a waist and these two lobes. And that's what I wound up studying. And even to this day, it's been almost 30 years. We're still not really sure how those things formed. It's kind of weird. And there's only been a handful of other objects like it where we've seen that sort of structure. And there have been some interesting ideas that look pretty convincing, but we're not 100% sure. So it's kind of nice to know that in my PhD thesis and all of that, I was able to say, yeah, these things are weird and we don't get them. And then even now it's like, yeah, we still don't really get them.
Right. And so one thing that you described, it was in 2 different episodes, but what's the difference between certain supernovae?
Oh, there are lots of different kinds. In general, you can split them into 2 types. And oddly enough, we call them type 1 and type 2. Type 2 is the kind that most people think of. You get a massive star. It's got 40, 50, 60 times the mass of the sun. And when it runs out of fuel in its core, and I'm like hugely glossing over details here.
It's
but,
good. It's fine.
When the center runs out of fuel, it collapses. It's fusing elements together and generating energy. And the core of the star really, really, really wants to collapse under its own gravity. But the energy it's generating is keeping it inflated. It's kind of like a hot air balloon. And if you remove that energy source, the core collapses. And so when it runs out of fuel, that's what happens. The core collapses. This sets up a lot of extremely complicated physics. But then what happens is in a split second, the very center of the core will release a vast amount of energy, basically as much as the entire star has given off its entire life. And all of that is compressed in time into just a split second. That generates a tremendous shock wave. It blasts outwards, blows out the outer layers of the star. They explode outwards at some large fraction of the speed of light. And that's a type 2 supernova. And there are lots of different flavors of these. Some of them, the star has blown off all of its outer layers before the core collapses. Some of them are spinning quickly, and all of these sort of change the characteristics of them. But in the end, they're all core collapse supernovae. That's actually a better term for them. That's what supernova 1987A was. The other kind is where you have a star like the sun, and it uses up all of its fuel, and it turns into a red giant, blows off its outer layers, and this time it's a much more gentle event. And what you're left with in the end is the core of the sun, which is highly compressed and very hot, and it's called a white dwarf. Now, if it so happens that star is orbiting another star, much like the sun, it can draw material off that star. The stuff falls onto the surface and piles up. And the gravity of the white dwarf is so intense that at some point, if it draws enough material, it fuses all of that material all at once. It's basically a thermonuclear bomb on the scale of, a star. And that is so much energy, it just rips through the star, blows it to pieces, and we get another kind of supernova. Coincidentally, they give off about the same amount of energy as the other kind, the core collapse, even though the mechanism is very different. And we call those type 1 supernovae. And again, there are all kinds of flavors of them, type 1A and P and C and all these kind of things. And basically, they're just different characteristics of them. But in the end, what you have here is a white dwarf that blows up.
Yeah.
I think that might be a record for speed of describing.
But that was perfect because
that makes any sense.
Oh, it makes so much sense. But a lot of people would wonder, and this was the first thing I had to look up, but I understood physics to a degree, but this was before I had actually taken so many physics courses. This is when I was much younger. So people are wondering, why does the white dwarf have so much gravity compared to something that would be, sun size?
Oh yeah, sure. That's a good question. And basically, the amount of gravity that you feel from an object depends on a couple of things. And one is how much stuff there is in the object, how much mass it has. The more massive an object, typically, the stronger the gravity is. And also your distance from it. The farther away you are from something, the weaker its gravity is. So as you get closer to it, the gravity gets stronger. Now, if you put these two things together, if you have a very massive object that's very small, that means it has a lot of mass, so it has a lot of gravity. But that also means you can get really, really close to it, so the gravity you feel from it can get incredibly strong. Now, right now, the sun has the mass of the sun, by definition, right? We call that one solar mass. And by the time the sun dies in about 6 billion years, it'll have blown off roughly half of its own mass. The solar wind over all these billions of years will have blown off half the sun's mass. The other half, though, will collapse down and form this white dwarf. And a white dwarf is only about the size of the Earth. So 8,000 miles, 13,000 kilometers. That's really small compared to the size of the sun. The sun is 100 times the diameter of the Earth right now. So imagine taking half the mass of the sun and compressing it down into a ball that's the size of the Earth.
Pretty dense.
And that's why the gravity is so strong. It's very small, so that if you're standing on the surface, the gravity you feel would be a lot more than Earth. And you know what? I don't know what the number is. I'm sure it's many, many, many thousands, maybe hundreds of thousands. I'm not really sure off the top of my head, but it's incredibly strong. And that's why white dwarfs can explode. As that matter from another star falls onto them, the gravity is so intense, it can squeeze that material and fuse it like a hydrogen bomb, and then it explodes.
Yeah, and we actually, and going on with this, Sprung, you had a really good question. I kind of hinted at it a little bit, but not fully. He said more mass typically has more gravity, but what makes something have less mass but more gravity?
It's not so much less mass but more gravity. If you're some distance away from an object, like well out, like you can see it way in the distance, the gravity you feel from it just depends on its mass and how far you are from it. But if you're standing on the surface of an object, things can get a little bit more complicated. So for example, the Earth has a certain amount of mass and a certain size. And so when you're standing on its surface, you feel a certain amount of gravity. We call that one Earth gravity. And it's just what it is. It makes you feel your weight. Now, if I were to increase Earth's mass without changing its size, then because it has more mass, you would feel more gravity. And the gravity that you feel when you're standing on the surface of an object, oddly enough, is called its surface gravity. And so the surface gravity of the Earth is what it is right now. If you were to double the mass and keep it the same size, the surface gravity will double. But if you keep the mass the same, but shrink it down, then again, the surface gravity will go up, because basically the object is smaller. It's kind of a funny concept. We measure gravity from the center of an object. So even though you're standing on the surface of the Earth and you can't get any closer to it, we kind of define the distance as how close you are to the center. So if the Earth were to shrink and stay the same mass, you're closer to the center. You're still standing on the surface, but now the surface is smaller. So the gravity you feel is stronger. And that's why white dwarfs have such strong gravity. That's why black holes have such strong gravity. If the sun were to turn into a black hole right now, we wouldn't feel any difference, gravitationally speaking. I mean, we'd freeze to death, and that would suck. But the gravity we feel would be exactly the same. But because the sun would be so much smaller, would only be a few kilometers across, you could get really, really, really close to it. And when that happens, the gravity you feel from it gets much, much, much stronger. And that's why black holes have such strong gravity.
There you go. Someone says, I get it now. That's amazing. Yay. Okay.
That's the whole point.
Yeah.
And it's funny, there are some things that are easy to explain sort of by waving your hands. And then there are concepts like that, like gravity, where it's not just your distance to the object. It's also at some point, when you get to the object, that's it. You're on the surface. You can't get any closer to it. That's how you think of it. But the way a scientist thinks of it is that, oh, no, we're measuring from the center of the object. So, how big it is will change how much gravity you feel on the surface. But the amount of gravity the object has in total, like if you were way far away from it, that hasn't changed.
Right.
It's weird to think of it that way. But that's how scientists think.
Yeah, and so of course I bring up a black hole because this is a galaxy, guys, that has a really cool one. It's a very weird galaxy, and people are saying, gravity time relation, please.
Yeah, no.
I do 6 hours of this a day.
That's a complicated topic. Basically, this goes back to Einstein. Mm-hmm. Who showed in his theory of general relativity that how we experience time depends on a lot of different things. So the time you all are experiencing is different than the time I'm experiencing because we're moving relative to each other. And you're thinking we are, and it's like, yeah, we're on a ball. We're on the surface of a ball that's spinning, and so I'm moving in one direction, you're moving in another. Is that right? Wait a minute. Maybe I shouldn't go with that example because I need to think of that more carefully. That might not be right. Let's put it this way. An astronaut in space, and there are a couple of astronauts, I think they're still on their spacewalk right now.
Mm-hmm.
They're orbiting around the Earth at roughly 8 kilometers per second. And it turns out the way they measure time is a little bit different than the way we do because they're moving relative to us. And you've probably heard about this. The faster you move relative to another person, the slower your clock ticks. So for the astronauts out there moving in space, their clocks are ticking a little bit more slowly than ours. But what also Einstein showed is that the relative gravity that you feel also changes the way your clock ticks. The closer you are to a source of gravity, the more gravity you feel, basically, the slower your clock ticks. And so basically you have to add both of these things together. Now for the Earth, the amount of gravitational change between here and the astronauts isn't very much. They're feeling about 90% of the gravity that we do. So the change in their clocks due to gravity is very, very small. It's much larger because they're moving so quickly. But it's an effect and it's real and you have to account for it. And the more gravity you have, the stronger the effect is. So as you fall into a black hole, your clock will tick more slowly than somebody who's really far away from that black hole. And by the time you reach the surface of the black hole, they don't really have a surface, but by the time you get there, your clock is basically ticking infinitely slowly relative to somebody far away. So when somebody sees you falling into a black hole, by the time you're right at sort of that moment, that part of the black hole where you're moving at the speed of light, you fall into the black hole, your clock is infinitely slow. There's just an infinite amount of time between between ticks. And that's not a mechanical effect. It's not like there's something changing in your clock. This is the way the universe works. This is woven into the fabric of how everything works. And it's bizarre. It's not how we're used to thinking, but we didn't evolve in a place where this kind of stuff happened all the time. So our brains have a hard time handling.
Yeah, and it's still something that is. But go on.
No, I was going to say, if it's confusing, trust me, it confuses everybody. I always have to sit down and think about it. I never took a class in relativity, so I have to sometimes really struggle to work this stuff out. It's hard.
It is, and I get all of the QM and something from nothing, and when I say nothing is something, and trying to really articulate that gets a little difficult because I know sometimes my brain gets tired, and then I just throw out things, and I'm like, wait, I said that wrong, and I know I said that wrong, and I don't even.
Yeah. Oh, and that's a real thing with communicating science is you have to know all this stuff, and then you have to communicate it effectively. And I did an interview yesterday. As a matter of fact, I haven't linked to it yet, but I recorded an interview with the local Colorado Public Radio, and I realized much later I said the wrong thing, and it's frustrating. I was talking about orbits and how this Chinese space station is going to fall in the next day or 2 or 3 days, something like that. Tiangong-1 its orbit is decaying. It's a couple 100 kilometers above the Earth's surface, and I'm not sure what the current height is right now, but it's basically the atmosphere there is really thin, but it's there, and as it's moving around the Earth, it's ramming its way through the atmosphere, and it's basically losing energy every time it hits an air molecule. It's giving a little bit of its energy to that molecule. And what that does is that lowers the orbit. The weird thing is, even though you're taking energy away from the orbit of this thing, it's moving faster because when you take away energy, the orbit drops. But when the orbit drops, it actually goes faster. The closer you orbit to the Earth, the faster your orbit is.
Mm-hmm.
And so I accidentally said yesterday, sorry, whacked into my desk there. I accidentally said this thing is ramming through the Earth's atmosphere, and it slows its orbit and drops down. And I realized later, it's like, no, actually it's removing energy from the orbit, drops down, and then that puts it into thicker air. So it drops down more and more and more. So right now, it's dropping faster every day.
Right.
And that's why in 3 days, it's just going to fall down into a part of the atmosphere that's thick enough. It'll mostly burn up. But I accidentally said it slows down, and that kind of stuff is maddening because
it is.
and I don't want to give people the wrong ideas, and I don't want to reinforce misconceptions, and that's hard.
Yeah, and I've had that happen quite a bit because, again, I'm live streaming this. And so
Yeah.
sometimes I'll say, I think even as far as how many stars are in our Milky Way galaxy, I think one time I was like, there's hundreds, it was like, anywhere between 200 to 400,000. And I stopped and I was like, that doesn't seem right. Or wait, millions and then billions. Sorry, guys, but brain gets tired. And then you have that segment and then people go and see it. And so you're like, there's not enough edits I can do to this. By the way, got this wrong. And but that's how that happens. And so it is hard. And I'm glad you actually said that, because as a communicator, taking the information you've learned and actually talking about it to somebody else, and also making sure that it's relatable, I guess, that they can understand a lot of that.
And doing it live is a nightmare. I've done a lot of live chats. I used to do them on Google Plus and YouTube. I had my own live thing for a while. And salute to you for doing this so much. It's hard. It's a lot of work. And you clearly have a much more sophisticated setup here with Twitch than I ever did. But it was tough, and you say a lot of wrong things. And even on Crash Course, or I was watching How the Universe Works a couple of nights ago. It's a TV show on Science Channel that I'm a talking head for. And every now and again, you hear something and you go, oh, that's wrong. And they slip through the cracks. You say something and you don't realize it. The fact checkers miss it. It happens. People ask me, advice for like writing a book or something. And I always tell them, I have very little advice about helping people write a book or anything like that, because everything I do in my own half-assed weird way. But the thing is, don't be disappointed when you get the draft back, the edits back, or it's published and there are errors in it. There will always be errors in it. And it doesn't matter how many fact checkers you have, how many editors you have, stuff slips through. It's just going to happen.
Absolutely. And you've written a few books, not recently, but you've had a few, haven't you?
Oh, thanks for reminding me. Were you my agent?
Nothing soon, okay?
I know. No, I'm kidding. I actually working on a book pitch right now with my agent. I just haven't had the wherewithal to get it all wrapped up in a bow yet. But yeah, I've written a couple of books. The first one was called Bad Astronomy, and it was about myths and misconceptions. The second one's called Death from the Skies, and that's all about the ways astronomical events can wipe out or at least damage life on Earth. I also did a third book. It was online with Zach Wiener-Smith from Saturday Morning Breakfast Cereal, the webcomic. And it's called 2 to the 7th Nerd Disses. Basically, it's 128 yo mama jokes. But, yo mama jokes are a little bit, there's most of them are body shaming and sexist and all that. So we said, how do we make this? Because we have all these nerd insults. What do we do? And we decided just to call them nerd insults and put them together into a book. And it was a lot of fun. You can find that online someplace. But it's tough to write a book like that. And then, you're reading it and realize, it's hard enough with astronomy when there are new discoveries all the time. And you write something and say, we've discovered dozens of planets orbiting other stars. And, 5 years later, now it's up to almost 4,000. And so it ages rapidly. But then to find something that's just an error, and you realize you said 1,000 instead of million or a billion or whatever. And it's just, which is why, I'll note, I don't debunk the way I used to. I used to be, it's easy to get really full of yourself. And it's like, oh, this person said this and it's clearly wrong. And now I'm going to be the comic book guy from The Simpsons. And that guy is a jerk.
Right.
And over time, I realized I was being kind of a jerk about all this stuff. So I pulled way back. Now, if it's something like public health or something important to the whole planet, like climate change, I reserve the right to be a little snippy for some of these folks. But in general, I try not to be quite as big of a jerk about things.
Yeah, as far as information about space, but other things that impact
or movie
us.
Reviews.
Oh man, yeah. Well, I know you and Neil deGrasse Tyson probably get a lot of. Everybody wants to know what you guys think about movies.
Right. And Neil, I love Neil. I've known Neil a long time. He can be on Twitter. I don't want to. Yeah, dismissive is the wrong word, but he can come down kind of hard on some of these things in the movies, and I always laugh when I see what he writes because it's like, oh yeah, he's gonna get responses for this. I totally get it. But it's really easy to review movies, especially when you're reviewing them to attack the science, to become an ass. And I saw myself doing that, and I backed off. And when I was still writing for Slate a few years ago, Slate.com,
Right.
my editors would, they'd approach me and say, "Are you going to review this movie? This is a huge blockbuster movie coming out. It's based on astronomy." And it was like, no, I really don't want to, because it's just no fun to come in there and say, I have to write down every mistake the movie makes and talk about it. I don't want to sound like a jerk. And in the meantime, I'm not watching the movie. I'm not enjoying the movie. I'm a huge science fiction nerd. I want to watch movies. I want to enjoy them.
Right.
I don't want to sit there with a pad and a pencil and literally a flexible flashlight strapped around my neck, taking notes in the theater.
Right.
So I almost never do that anymore.
Yeah, being like, Gravity, the tether thing was completely wrong. It's okay though,
Yeah, Gravity and Interstellar were, I think, the last two movies I reviewed.
Yeah.
And also, it's funny. I enjoyed Gravity as a movie.
Mm-hmm.
Me too. Tense.
Me too.
The science in it was nonsense.
Right.
And I know the science advisor for that movie. He's a friend of mine. And when the movie came out, I remember talking to him about it. And I knew what had happened. Basically, the big plot points that depended on bad science were already in the script before they brought him in. And all he can do is sort of say, okay, given that, what can I do? How can I make this part accurate or this part better? Or they're going to have this happen. How do I make sure that's accurate? That is the burden of every science advisor. I mean, I'm working on a TV show right now called Salvation. Mm-hmm. It's on CBS.
Oh.
The first season, I think, is on Netflix. And it's about a giant asteroid that's seen approaching the Earth and what can we do to prevent the impact. And the problem is there's just going to be science in it that isn't accurate, because if you have a big asteroid coming toward Earth, it takes decades.
Right.
First of all, it takes decades for it to come and hit us, but it also takes decades to do anything about it. And they wanted to have a lot of tension, so it has to happen in 187 days.
Oh, man.
And I said, well, and I told them, that can't happen. You can't do that. And they were like, well, that's the way it's going to be. And it's like, all right. And they wanted to have this new technology rocket called an EM drive.
Uh-huh.
And I said, well, that's a real thing.
Yeah.
But it doesn't work. It violates every law of physics that we know. And every test on this thing shows that it's not really working the way these guys claim. And they said, no, but we want it. And I said, okay, this is science fiction. So given these parameters, what can I do to at least introduce real science topics, have it play out as best I can?
Mm-hmm.
And over the course of the season, that's what I did. And we're working on the second season now. The scripts are being written. I've actually just got one this morning and I have to look at it. And it's the same sort of thing. It's like, well, we've got new science coming in, and I've talked to them about, well, we can do this and this. And I said, off the bat, it's like, this can't work in the timeline we're talking about here. But in science fiction space, let's say it does. And so that's what I'm trying to do, is at least get these concepts out there and treat them as best I can.
Yeah.
And then they do what they will with them. And it's science fiction. Star Trek has warp drive and transporters and all this stuff that doesn't work or can't possibly work. But I don't care, because as long as it's treated consistently in the story, scientists are depicted as best I can depict them and all that stuff, then I'm happy.
Yeah. And then I get all the warp drive questions.
Right.
And then I get all the people that are like, can't we do warp drive? Or what about wormholes? What about white holes? What about faster than light?
I'm seeing the chat room here, and people are talking about the EM drive, the unicorn of astroengineering. I like that. Somebody's saying the EM drive is correct according to quantum physics, and it's like, well, the problem with the EM drive is that it's a reactionless drive. You're getting thrust, but you're not throwing anything out the back, and that you just can't do that. It's violating Newton's third law, and we know that Newton's third law is pretty good. Yeah. So unless these guys can show that what they're doing is real, and all the tests they're doing are not great, and nobody independent has come in and checked these things. So I'm very, very skeptical about the EM drive. But as a science fiction device, hey, why not?
Sure. And let's see. There were some other questions.
Yeah, I'm looking at this. Yeah, hey, yeah, I'm reading the chat room here. Stargates, that would be fun. I love Stargate TV show.
Yeah. No, that one was a good one. Well, I don't know if, I don't think that's still ongoing, is it?
Kind of, actually. I started watching it when Stargate Universe came out because John Scalzi, who was a science fiction writer, was involved with it. And I hadn't watched Stargate. I'm a huge Star Trek fan and all that, but I had never actually watched Stargate. So I watched Stargate Universe and was totally blown away by it. Went back and watched SG-1 and then Atlantis. Now they're not making any more movies or anything, but there's an online version called Stargate Origins. It's a subscription service, and I've got it. I just haven't watched the show yet. I got to sit down and do that. Looks pretty good.
Yeah, everybody.
I love that idea of creating these wormholes, and the whole mythology they put together was amazing. It was just a lot of fun. And going to science fiction conventions and everything, I've met some of the writers and some of the actors, and they're really, really fun people. And a lot of them are interested in science. This is another thing I'm really excited about. If you watch Stargate Universe, Eli, the young math and physics genius, who's basically learns how the ship works and everything. David Blue is the actor. He's on Twitter and Instagram. I think it's just David Blue on Twitter. I have to look that up. But he's a huge science nerd. Loves it, and was reading all about it during Stargate. And by the way, Stargate Universe had a science advisor, Micah McKinnon, who's a geologist, and she's very, 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 very smart.
Mm-hmm.
And so she helped them with a lot of their science. And so Dave is I've talked to him many times. He loves it, and I see that a lot in science fiction these days. That a lot of the actors are really, really, they grew up with Star Trek, they grew up with Star Wars, and now they're acting in these science fiction shows, and they love the science fiction, and they're fascinated by the science, and that makes me so happy because that stuff inspired me when I was a kid.
Yeah, but so going on with that topic, that I'm sorry, I'm going to go back because it was sitting in my brain for a minute, for a good while. As far as like debunking things and then not wanting to seem, kind of like a snob. I get that too, because I get a lot of questions.
They say the word dick. That's
yeah, you actually can. This is all completely at the, whatever. I prefer to have people be themselves, and because
that's about as sweary as I'll get in public.
Yeah, no, but that's well, yeah, no, it's good because that's what I like about Twitch is there's a lot of leniency with being me and talking about this. When I talk about space, it's pretty vulgar, but it's good. It's funny, and it gives me the names like Galactic Bulge. Like please. But so
debunking and dickery, yeah,
right. And so but one of the things that you wrote about that I had already known, but you wrote about it because I'm not sure if it was for Slate. I think it was for Slate. The proper motion of our solar system on the Milky Way. That viral video, because that one does trigger me. The one that went viral, yeah, it triggers me. Yeah,
because makes you angry.
Yeah, when I look at it, I'm like, that's not right at all. And then you wrote about it, but of course, the way you wrote about it was so much better. I actually drew it out. This sounds really stupid, but I was actually in the bathtub, and I'm like, I need to draw this out, how this would work, and so we talked about it on my stream the next day. But it's one of those things. I don't know how many people in my chat, and I'm sure a lot of people have seen it because a lot of people get their information about space from YouTube. And that's one of the things that went viral.
Yeah. The thing that bugs me is how anybody can put out information. And if they do it in a way that seems, cool and seems like they have a bit of authority behind them, then people will just eat it up. And that particular video, it bugged me because it sort of the basis of it was the things he was trying to say weren't that far off, but the depiction and the words he was using and the way he was describing it were really reinforcing a lot of terrible misconceptions about motion. And as I was reading more about this, and I was like, why, who is this person who is putting this out? And it turns out they believed in a lot of
other things.
paranormal, not paranormal, anti-science sort of new agey stuff that was completely wrong. And so I basically jumped in and said, yeah, this doesn't work that way. And now, that stuff goes viral. It pops up every now and again. What's really getting me now are these Twitter and Instagram accounts that basically steal content.
Mm-hmm.
So there's a ton of them, and they typically have names like world and universe and cool astronomy pics and that sort of thing. And they'll just grab a picture from Hubble or whatever, post it with a one-line description, and they have like 1 million followers because people are they're hungry for factoids that are cool. And so if somebody puts up a picture and says, here's the aurora as seen from space, and here's this picture of the Earth with like this crown of green light around it, everybody goes, oh my God, that's amazing. And I look at that and go, it's not real. Right. I know that's from an animation done at Goddard Space Flight Center at a NASA research center. It's an animation that was done to talk about how the aurora forms on the Earth. But people see that and think it's real, and it's like, well, that's not what it looks like. And so it's misleading. It gives you all kinds of wrong ideas about the aurora. And then plus, aggravatingly, these people never credit where the pictures come from. So you can't learn anymore. And, for that particular example, it's not that bad. But then they'll show, here's a Hubble picture of the Earth. And it's like, no, it's not. It's just not a Hubble picture of the Earth. Hubble can't see the whole Earth at once. It's only a few hundred miles up. It sees a little tiny piece of the Earth when it looks down. And the facts are sometimes just grossly wrong. Plus, if they're not crediting Hubble, that's one thing. But if they're using an amateur photographer, amateur astronomer, or an astrophotographer, or their stuff, it's content stealing.
Right.
And I find that very frustrating. And it's those kind of accounts that are reposting that vortex, the helical vortex, the vortex motion, that's it, of the solar system, and keeping that stuff out there. And in my opinion, they're doing way more damage than they're doing good.
Yeah, no, I agree. And that's one thing, like, for instance, today, even when I sat down, I said, guys, everything that I showed you yesterday, I usually put in the VOD description. If I'm using, like, for instance, if I use one of your videos and we're watching it here to explain something super quick, you have to put that in you have to source that. And I think that's super important because that's not me talking. That's if someone wants to go back and be like, well, that's cool information, they can go back to the source and look at the other things and everything. It's so important. So like today, for instance, I can't edit my VOD from last night. So I can't actually go in and put in the links. So I apologize, like, first and foremost, like, today to everybody. Like, there's so much, and I hit my mic too. So you hit your desk and I hit my mic.
Yeah, I've got a slide out drawer here. You can't see it, but my mic is, what? And this is bugging me too.
What's that? Oh, yeah.
I'm not centered, and that really irritates me. But then, if it goes down too much, you're going to see all the crap on my floor and the fact that I'm not wearing pants. So
half of Twitch chat isn't either. It's okay.
How does that? But of course now it's 30 seconds. Oh, that's better. Okay.
Yeah. So I can move you around too.
No, that's okay. We're good.
But yeah, so crediting is really important, and that's one thing that I don't see happen much. And if so, all this stuff I will spend actually. When I'm done with my streams, whether it be that night or early in the morning, I could spend a good 30 minutes just putting together the links. So I have to preserve those. Everybody's like, there's so many tabs. I'm like, yeah, I'm saving them. Because if I show you an image and it's not something I made, somebody else made that and I want to give you the link to it. So, yeah, it's important. It's so important. It's also important not to misrepresent what other people are saying too, like everybody's doing with Stephen Hawking right now. And yeah,
I had this conversation recently with some people on Twitter, because I didn't. What I do when I typically promote my blog in the morning on Twitter, I'll say I'll have a line or two that's like intriguing. You can call it clickbait if you want. I don't think it's not like you won't believe what happens next. I almost never do stuff like that.
Right.
But I want to catch people's attention. Then I'll have a link to the blog post, and then I'll include a picture that's usually sort of the lead picture from the post. And somebody I know was saying I should really credit the person who took that picture in the tweet. And I thought, that's interesting, because I give them full credit and link and everything in the blog post. So if you click the link to the blog post, it's all there. And typically the picture I put up in Twitter is small and not very high resolution. And the problem is, I kind of agree. A lot of people don't click through the link; they'll just click the picture, and it's nice for them to have whoever took it to have the credit in the tweet. The problem is, and now that we have 280 characters, that gives you room to credit the person. The problem is, it sort of takes away from the attention span of the person. I want that person to click my link. I don't want them to just look at the picture. The picture's great. They're pretty. I love pretty pictures. But if you go to my blog post, you'll get the science behind it. You'll get the story behind why that picture is so cool. Maybe why it's pretty. Maybe it's an optical illusion I'm explaining. Maybe I'm talking about the person who took it and I'm giving the details of how they did it. And I don't want them to not click the link. And I'm concerned that if I credit them in the tweet, it'll do that. It'll make it harder even for people to click the link, or you're just less likely to. And so it's maddening. I just don't know what to do. There's right and there's right, and I don't know. So I'm thinking this through right now. I'm just trying to figure it out.
Yeah, someone just said it's going to be tough, man. It would be. It is. And everybody that's tuning in right now, I see a lot. Whenever I show Earth, this happens. So I do have to ask you, because I know that a lot of people in here are just trolling, which they're just.
Really?
I know. I know. You never deal with that ever,
Yeah.
especially on Twitter. Never, ever, ever. Because sometimes I read through your comments that people are sending to you, the replies, and I'm like, well, okay, good.
Yeah, I don't even read my YouTube comments anymore.
Yeah, me neither. So what do you do? What do you think about this? And I don't think it's not a new rise necessarily. This whole flat Earth thing. I mean, I have a sweet emote just because I think it's really funny, and I like to meme. If they want to meme, then I'll meme right back with an emote. But it's not getting, like, what do you do with that?
With flat Earth people?
Yeah.
I ignore them.
Yeah.
I used to fret about which kinds of nonsense to talk about, and it got to the some things are just so ridiculous and small. It's you put something on a website and it's seen and you read it and it's like, oh my God, how many people are going to read this? And the answer typically is not that many. If somebody thinks that their parents are lizard people, it's probably not that many people out there, and you could spend 6 hours writing about it and ripping apart this idea. But really what you're doing is you've just talked to 10 people about this, and it's not a very good ratio of time spent to amount of information actually received, and so there's sort of you have to deal with that ratio in your head. And it turns out, well, back in the year 2000, when the moon hoax idea was getting to be really popular, I was thinking about writing this anyway. Then Fox TV came out with that TV show, and it turns out, well, that's going to have a couple of million viewers or more. That's absolutely worth my time. Up to that point, the moon hoax, the idea that NASA faked the moon landings, was just sort of a really fringe idea. Nobody really believed in it. It was just kind of a thing that a few people were trying to make money off of. But then that show came out and a few other things happened, and it got really big. So you have to make that decision for yourself. And the thing with the flat Earth is that this has been around forever, these people who believe it. Even now, I don't think it's as big as you think.
Yeah.
Some basketball player, I think it was, and it was a rapper a couple of years ago, we're talking about it. And I thought, well, that's silly, and maybe people will look into it. But I think what they'll find is the evidence that the Earth is round is overwhelming. But the problem with the internet and TV and TV news and everything, relying on fringe ideas to generate eyeballs watching their show, is that they focus on these folks. And so you get this guy who built himself a rocket and launched himself up. I don't even know how far. It wasn't very far, a couple of thousand feet, to prove the Earth is flat. It's like, it's not going to work. To really, when you look at the math, you have to get up 60, 70, 80,000 feet off the Earth's surface before you can start to really notice the curvature of the Earth really easily. And when you're in orbit, then you see it very clearly. The Earth is very clearly a circle. when you look down on it and as you orbit it, you see that it always looks like a circle. The only kind of object that always looks like a circle is a sphere. And in fact, I was on a Star Trek cruise a few months ago, and which was a huge amount of fun. And they had an astronaut up there, and he was giving a talk, and we were in the audience. I was listening, and he mentions the flat Earth people. He gets a lot of notes from them, and he asked me, he points me out in the audience, and he says, "What do you do with these people?" And I said, we're on a cruise right now, in the Caribbean. We're south of Florida right now. I live in Colorado. I'm at 40 degrees north latitude. Right now, we're at about 20 degrees north latitude. And you can go out of your cabin and look at Polaris, and it's noticeably different in the sky. It's not nearly as high up in the sky as it is from Colorado.
From Colorado, yeah.
That's proof that the Earth is round. If I'm up in Colorado and I see Polaris this way, and I move around the Earth, I'm going to see it this way. It's in a different part of the sky. And so, boom, Earth is round. And so this flat Earth stuff is ridiculous. I could list 100 reasons it's wrong. And it's just one of these things where it's like, do I really want to do this? Are some ideas just too dumb to tear apart? And I've seen a few things covering it. And if I had to do it, I'd want to sit down and do it. It would take me probably 2 or 3 weeks to write up every single thing. And who wants to read a 30,000 word treatise on why the Earth is round? But then what happens is it becomes sort of the go-to place.
Right.
And that's what happened with the moon hoax. And I have an astrology article I wrote, and it's like, I can just send people there. So I'm still considering it, but it's just one of these things where it's just, it's pulling teeth. Do I really want to do this?
I know. I try to not engage it too much, other than saying, we have this figured out. Eratosthenes, all of this a while ago, and I just kind of leave it there.
Yeah, 2000 BC, 2500 BC, Eratosthenes figures out. I mean, they knew the Earth was round. He was able to figure out.
He got a pretty good. Yeah, he got a good circumference there. It was pretty impressive.
Yeah, and
for the time,
there's a lot of ways you can do this, and again, it's like, how do you tackle this? This is like a book's worth of information. I can say, Polaris changes with latitude. We have time zones. You can pick up the phone and call somebody in New York and say, is the sun up? And they say no. When you're in California, you're like, aha, the sun is setting for me, but for them it's already set. The Earth is round. There's a lot of things like that. But there's also just, then if the Earth were flat, what would you see? And interesting things like, what would the gravity be like if the Earth were a flat disk? Eclipses. Why is the Earth flat and nothing else is? And the other thing is that then you start looking at the people who are promoting this,
right?
The people who believe in it. Like, was it the rapper's name? B.O.B. is what's coming to mind. I think that's right. And the basketball player, they're just reading this stuff and believing it. When you go and find the promoters of this stuff, there's this one guy who's out there, and he's a bad dude, super religious anti-Semite, and a biblical realist, a literalist. So he's and that's, if people want to interpret the Bible the way they want to interpret it, fine. If you're trying to extrapolate that into real life, you're going to run into some scientific issues.
Right.
But in this case, he's also an anti-Semite, and like a bad one. And when you read this stuff, it's like, oh. And so, reading it is like, it's kind of like digging through your trash for something you accidentally threw away. It's just,
yeah.
And I just don't want, after a while, it's like, do I want to deal with this, or do I want to write about
things that matter?
This cool galaxy they just found that maybe doesn't have dark matter.
Right.
That's cool. I want to talk about that, not about this other stuff.
Yeah, that's pretty much how I see it too. So I make I'll just laugh and do a nod and be like, flat Earth, let's go. And just, because, whatever, like there's those people that actually do believe that, there's nothing. They'll deny anything.
Right. And once they do that, you're done. I mean, once it's kind of like climate change or some of this, I've done a couple of debunking videos on YouTube, and they say, well, I'm just part of the government cover up. And it's like, well, then we're done.
Yeah. But why do people think the government's so, that's one of the things that bothers me is like, where did this wave of just like paranoia? Now I know it's been there. Granted, I mean, you can see that in even documentaries made on people that have been wrongly accused of certain things and whatever. But there's so much, I feel like the flat earthers and the people that are like fake moon, we didn't go, it's a green screen, which is funny. Like I think about it and I'm like, why are you guys like looking over your shoulder like that so much?
That's been around forever.
Yeah,
It
that's
really has been. All these conspiracy theories, and the thing about conspiracy theories is sometimes they're true. Watergate happened,
yeah, right.
and so and Iran Contra happened, and all the. I mean, look at the huge conspiracies and cover-ups were happening in the government right now. There's a lot of this stuff happening, so they're real. And there's people with certain personality types can really see conspiracy theories everywhere, and so it's easy for that to happen. These people are in a vast minority. The problem is now they have a voice. When you get 100 people together on on a YouTube channel, on a website, or groups on Twitter, or whatever, it seems like a much larger chorus than it is. This is how Russia, these Russian Twitter bots, we know this is real, are going in and they're making Facebook posts, which are some of them were rabidly pro-Trump and some were rabidly anti-Trump. They're trying to polarize us. They're trying to split us and paralyze the government. This has been shown. This is not a conspiracy. This is a fact.
Right.
And so it's easy to put an army of bots out there, and you don't have to have that many to really make it look like you've got a much larger voice than you have. And it's kind of the problem with the internet. It's been this great thing where it's given everybody a voice, but it's been this epic disaster because it's given everybody a voice.
I agree. Like some guy was able to, it looks like he might have lived in his car, make a video about how the sun is hollow. And it's, he's like, there's, and sometimes every now and again, we just watch it because a lot of my chat is they're gonna laugh along with me, but yeah, and I don't even think that guy that's taken that rocket thing to try to prove the Earth. I think he's just all about the publicity at this point. He's not even trying. In my head, I
don't know his motivations.
I don't either. Just publicity is all I'm thinking at this point.
And and I try not to. I've done this before a lot too, because sometimes these people may have mental health issues.
Yeah.
Promoting some of these conspiracy theories, and I've dealt with that.
Yeah.
And so I don't necessarily. And sometimes, and I'll add, sometimes they're just con artists. They're out there trying to defraud the public to make money. So I try not to ascribe motivations necessarily, unless it's like that anti-Semite flat earther,
right.
Screw him. But I just try to avoid that and deal with the facts, and maybe bring that stuff up if it's like, it's funny that this person is doing it this way. But good heavens, I mean, you must deal with this way more than I do.
Yeah.
Having a chat room and a live TV show like this.
Yeah, like right now I just timed out the word and someone was answering a question. I flagged it immediately because I was like, I don't want that to look wrong. Sorry. Yeah, it's a lot. And with the Twitch, you get such a different, it's a lot of demographics, but I try to as best appeal to, I guess you could say, the average of the two. Because I do have people that are older in here that absolutely know astronomy from when they were younger, and then I have also teenagers in here. So yeah, sure. Sorry, I timed out the word. Yeah, it's awesome, and I'm so glad that you were able to come on here and talk about it, because I think it has a place here, and I've been fighting for this for a while. And also, you live very close to where I live. I think I'm not going to drop the name of where I live just because, there's a lot of people here, and I, but you live, I think, within like 5 minutes of where I live.
Oh, really? I'm in the wilds of Boulder County. I used to live closer to Boulder, but I moved out in the country a few years ago.
Yeah, no, I'm in that developing area where there's nice municipal fiber internet now.
I have satellite because I'm pretty rural.
Yeah.
So it's not great. Good enough to do this.
Yeah, no, they're starting to build in that area that was pretty rural, where there's a lot of farms and stuff. But
yeah, it's not going to happen where I am. But yeah, it's kind of funny. When I lived closer to Boulder, my skies were darker because of where I was. My location, where was I? I was north and east of Boulder, and so my southwest sky was good. But now, so I moved out in the country. There's a bunch of towns to my southwest. And that's kind of, that's where all the good stuff is. Mm-hmm. Typically, when Orion is rising and all that. So now, taking out my scope. I mean, if I tilt my camera, you'd see all my telescope stuff on the floor over here. I'm tuning it all up and trying to get it ready for the weather being warmer again. But yeah, what are you going to do?
Yeah, yeah, exactly. Someone just dropped it, but that's fine. That's not exactly where I live, but close to it.
Yeah.
So yeah, so that's
Somebody in Loveland. Hi, Loveland person. It just scrolled past. I missed that.
yeah, and someone said FOCO too, so Fort Collins. You're a bit north, but yeah, goats. Yes, he has goats, guys.
Oh, I see. Yeah.
And they're really smart. You guys have no idea. Goats are really smart. People are
They're
like, what?
clever, but they're not smart. There's a
Okay,
difference.
clever. Okay, clever. Redacted.
Yeah, they're if you leave a door open for even a second, or there's a hole in the fence, they'll figure that out. It's kind of amazing watching that process go. But then the stuff they just follow each other. If one of them's like, "Hey, what was that?" and they wander off, the other ones are like, "Oh, I'll follow you." So there's a difference between it's kind of like book learning versus street smarts. They have street smarts, but they're not very good at the book learning. So yeah, it's kind of nice. We moved out here just to get away, and then we decided to have animals. So we've got some goats and a couple of horses. I think you're mandated if you live in the country in Colorado, you have to have horses.
Yeah,
it's kind of nice.
Yeah, and I really miss it. I've been here in Philadelphia for a while. I miss my mountains.
Oh, I thought you were still here.
No, I'm visiting right now, so I'll be flying back next week. But I've been visiting out here because I'm helping with the first. I don't know if you've ever heard of First Inspires.
Which one?
First Inspires. It's a non-profit organization where they build robots.
I don't know that.
Yeah, so they encourage kids to get into STEM, and they have these different levels.
Write that down.
Yeah, it's amazing. It was founded by Dean Kamen, the guy that he was the inventor of the Segway, the dialysis pump, and yeah. So it's getting kids involved in STEM. So I'm going to be hosting the World Championship of the first robotics competition at the end of next month. So it's awesome. And people, it's so incredible seeing kids, teenagers build these really complex robots that have autonomous functions where they are hands off and they compete and they also work together. It's an amazing thing. So, yeah.
Things have changed a lot.
Yeah, and it's going to be here on Twitch too. So they've moved over to Twitch. They've got a channel here. So I'm hoping more of this stuff kind of picks up, more of the STEM, and that's what I'm advocating for. So I do appreciate you coming on here. And
my pleasure.
Yeah. So hopefully, if you're ever available again, I can check and then we can have you back on.
Yeah, send me a note.
Yeah. So thank you so much. I will definitely let you go because I know it's been the hour and I appreciate it and I want to be respectful of your time.
Oh, look at that. It is. It's noon.
Mm-hmm. I know. It's great, but
I just and
no. It was perfect. No, it's perfect. It's exactly what I need, and I need help, and I appreciate the support too. With as you said, carrying on live for 6 hours, and it's tough.
When's Pamela on?
Pamela is, I think so. She's going to be back. She should be back now, but
she was in Japan, right?
Yeah, she went to Israel and then went back and then came back to her home for like 3 days and was like, "Hi," and then she's like, "I'm going to Japan."
Travels so much, but that's what she's doing. She's a science communicator, and there was a science communication meeting in Japan, so
yeah. And she's on every Saturday usually. I think this Saturday I have plans. But I think she might still do her stuff. Yeah, because she's got
I'm
Cosmic
so out of it. I
Quest.
don't even know what everybody's doing anymore. I can't keep track of everybody and everything they're doing. It's
I'm
amazing.
trying to bring everybody to Twitch. I'm trying. So Pamela's got Cosmic Quest on here.
I didn't know she'd switched to see.
Yeah, I know. And she's got her own channel too, and she paints planets and we come on here and we have beers together and talk about, just casual astronomy.
I've seen her talking about that stuff on Twitter, but I just assumed it was Cosmo Quest Live, that she was still doing it on YouTube.
No, that's me. I don't think Cosmic Quest I don't think we can have beers on Cosmic Quest.
Astronomy Cast, I mean. Okay.
Oh,
and their live astronomy stuff. Okay.
Yeah, no.
Like I said, it's funny, once you get into sort of this community and the social outreach people who are doing it on social media and everything, it's just impossible to keep up. I didn't think it would be this hard. But everybody's doing a million things, and I'll go to Comic-Con or something and bump into somebody. It's like, "Oh, hey," and they'll say, "Oh, yeah, I just did this thing." And it's like, "Wait, what? you just did a TV show? You just did this or that?" And I'm like, I can't believe, all the work that everybody's doing, and it makes me I'm just sitting here in my room. It's like, I got to get to work. I've got to work. I got to do more stuff.
Well, the AAS is Denver this summer.
I'll be down there for a day. It's the American Astronomical Society semi-annual meeting.
Yeah.
I'm going down for one day, basically just to hang out and meet up with some friends. I don't do research anymore. And I used to go to the meetings and, I'd interview scientists and all that, but it became such a nightmare trying to keep up with everything and get everything written. And then what I was finding is when I was posting like 2 or 3 news things a day, my traffic was dropping.
Huh.
People don't want to just see news articles coming at them like a fire hose.
Right.
So I just stopped doing it. It wasn't worth my time.
Yeah. Yeah. Well, that will be my first one going to it. And I'm hoping that, I'm a little nervous because it's right here. So I have no excuse. The last time I couldn't because I had other travel plans. But yeah.
You going as press?
Yes. Yes.
Okay.
Yes. So panelists.
I'm just going to gate crash, I think. Just
yeah.
show up and hang out for a while. I've got a friend I'm meeting later. I haven't seen in many, many years. So it'll be fun.
Yeah, it will be. And yeah, so that's it. And guys, thank you again, everybody in here, for your questions. Hopefully we can get him back at some time. He is really busy. He is. So,
taking care of my goats and tweeting pictures all the time. Yeah.
Well, thank you so much. And I will catch you soon, Phil.
All right. Thank you.
Yeah.
I really appreciate you having me on. Thanks.
Awesome. Take care.
All right. Bye-bye.
Bye.
Bye, everybody.
Okay, guys, I am going to go ahead and take a small break real quick. I can put on a video